All right, all we have is a couple sample problems, but there's a lot that's going to happen. So hang tough, rewind it if something doesn't make sense. There's a little bit of a pre-lesson coming at you right now. I decided not to talk about it during your real pre-lesson because it didn't apply to anything. So what do you do if you have a fraction with a negative exponent? And I'm not going to talk about it much. You just flip it. So that's going to equal 2. It's just flipped, 2. So how about this one? That'd be the same thing as 3/2. So it's very important to understand as we plug things in to kind of get our generic graph. Now some of you are going, well, didn't you tell us they all look like that? Something happens, I want to make sure you understand this, when b is less than 1, which is a fraction. So let's plug away and let's talk. So if we put a -2 right here, and again, you could type this in your calculator, but you should know how to do the math too. And I go -2. Well, that negative flips it, and then once we've flipped it, the negative goes away, and so you'd be left with 2 squared, which is 4. Now if I put a -1 in, this one, I flip it, but there's a 1 there, so that's just 2. Oh, I forgot. I got to times it by 5, so this would be 20. And I multiply that by 5, so this would be 10. And then I plug a 0 in there. Anything to the 0 power is 1, so this is 1 times 5 is 5. And if I put a 1 in there, it's just 1/2 to the first, so it's like 1/2 times 5 is 2.5. If I put a 2 in there, 1/2 times 1/2 is 1/4. Times 5 would be 5/4, which is 1.25. A little bit of mental arithmetic. Here's the point. 0, 5 is right here. That's my y-intercept. Now in the previous ones, all of my y-intercepts were 0, 1. Why did this one change? Because the previous problems, that was a 1. Now we have a 5. So that's what elevated the y-intercept up 5. And now -110 would be like bing, and then way up here. -220, you can kind of see where this is going, way up there. You can see this is coming in like this, and then 2.5 would be right about there. 1.25 would be right there, so you can see that this is coming this way. Now, what did we just learn? Well, I haven't said it yet, and I'm not even supposed to say it because this is for day 2 stuff. But if this is a graph of my business, and I want to make money, and this represents business, and I start here, and my business, is that looking like a good graph or a bad graph? This is a bad graph. This is actually called exponential decay. It's okay, you know, when pollution decays, but your finances, you don't want that. So this is a downhill, again, we're thinking left to right graph. The other ones, they all look like this. Like, okay, there we go. My business projection is looking really good. Or this could be, you know, like the deer population in Kent County. It's just exploding. Anyways, what's the asymptote of this? Well, once again, you can see it's going towards the x-axis. So it's just the x-axis, which is the same thing as y equals 0. What about the end behavior? Don't forget this. This is an always, always, always. End behavior has 2 parts. As x goes to -infinity, what does y do? And as x goes to positive infinity, what does y do? That's what you lock into every time you see this phrase end behavior. So I travel left, that's what this is saying. So here's my guy. I'm trying to go left, but I'd have to go up. My end behavior would be infinity. Now, as my guy travels to the right, what happens to y? Well, he's traveling this way, he's going down, he's trying to get to the x-axis, but the lowest point he gets to is 0, but he never touches it. So basically, y is greater than 0, or you could say 0 is the end behavior, but remember, he never touches that low. So we got to be able to communicate that somehow. All right, one more example coming. last problem in your example problem. So, if f of x equals 5 to the x power, remember there's a times 1 there. There's my a, there's my b. Sometimes you forget that little detail. What do g of x equals 5 to the x plus 3 power and h of x equals 5 to the negative x power look like? In other words, graph them. So don't forget, this is piggybacking. Whoops, there's a little b in there. This. But there's going to be a little twist. Now, I'd recommend that if you don't trust what I'm saying, go to Desmos, type it in, let the picture tell you what's going on. But I'm not going to take the time to do that. So, what does this look like? Well, essentially, it's our parent function. 0, 1 is our starting point. If you don't believe it, you plug 0 in for x. So 5 to the 0 power, forget about the 1. Anything to the 0 power is 1. So it's 1 times 1, which is 1. And then I go, okay, it's just one of these. Again, is that going to be a little different than if that was a 3 or a 4? Yeah, a little. So this is just get close. Now, what does this x plus 3 do? Well, this x plus 3 comes here. What if I had x plus 3 right there? I'd go left 3. And that's the same thing that does, even though it's up in the exponent. So I'm going to do this in red. I'm going to move the purple one left 3. So that point right there for sure is 0, 1. I know that point. So I got to go 1, 2, 3. So now I know this is 3, 1. And then I try to just duplicate it to the best of my ability. And then they're going to ask us questions about it. They're going to say, okay, how do the intercepts and the asymptotes compare? That's just a fancy way of saying what are the intercepts and what are the asymptotes. So let's start with the purple one, the original one. What are the intercepts? Well, that's 0, 1. We talked about that. What's the intercept for the red one? Oh, interesting. I didn't think about this one. So, okay, we got to figure that out. So remember, this goes back to, we can see that this looks like my intercept the way I have it drawn. Now remember, my drawing is way inaccurate, and I'm going to prove that to you in a second. But if we're trying to find the y-intercept, that's right in here. We got to let x equal 0 and plug it in, because any point on the y-axis is going to be 0 something. So we got to figure it out by plugging in 0 right here. Well, 0 plus 3 is 3. 5 cubed is 125. I am way off, which means this thing starts shooting up way faster than I thought it did. And then it finally goes through the x-axis, way up there at 125. So that'd be 0, 125. All right, I didn't see that coming. But they both share the same asymptote. Now this purple one's going to get there close faster, but the red one is eventually going to get there too. So it's the y equals 0 is one way of saying it, but another way of saying it, it's just the x-intercept. Okay. Now I don't want to make this too messy, but so I'm going to get rid of this and do it again for this one. Well, what does this negative mean if there's a negative in front of the x? Well, you might, let me pause this a second. Okay, what I was trying to say is you might recall us thinking, okay, what is this? Is this A or is this B? Well, notice we said if B, it's the thing, the coefficient of x. If that's negative, and you guys haven't seen this very often, it's going to reflect it over the y-axis. So this is my y-axis, so I have to spin my y-axis, and so this portion would come over here. This portion would just kind of flip like that. Mirror images over the y-axis. And so now it's going to ask us, all right, how do their intercepts compare? Well, they have the same y-intercept, 0, 1. What about the asymptotes? Well, they have the same asymptote, they're just going in the different directions. So they share the same asymptote. So that's a review of asymptotes, intercepts, and general graphing rules on top of getting to know this weird thing called exponential functions. But I think you're on board. I think you're ready to go to your homework. And good luck.